Now, one thing that's worth remembering is that often when we conduct some sort of a survey, what we're trying to do with the results is extrapolate and say, hey, they might be relevant to what we would find if we surveyed the entire population. Now, surveying a whole population is expensive and difficult, so we want to survey a smaller sample group, and hopefully the results that we get are going to be accurate as an estimate, I suppose, of what we would get if we sampled the whole population. So we can use the methods that we've found in this lesson to help us find the probability of a certain experiment, i.e. a survey of some sort, giving us a good estimate of some proportion that we might know. Now, this helps us design experiments where the outcome needs to be relevant. So the design of experiment is really based around, well, how many people should we survey? And it's the number of people that we survey that will really change the data here and tell us whether our survey is likely to give us a good estimate of what we're looking for. So this is a bit of a strange question because we've actually got a known proportion here, and I've made it something suitably a tiny bit ridiculous, I suppose, just to kind of put it into some sort of context. Now, let's imagine it is known that 1/4 of all Australians like anchovies. All right, we decide to test this by surveying 2,000 people. Now, if the results of our work down here don't give us the numbers we want, perhaps we would like to change this and say, no, 2,000 wouldn't be enough. And we could design our experiments suitably so that we can have more confidence in the results that we get and how they might translate to the whole population. So we're going to survey 2,000 people and say, do you like anchovies or not? They're going to give us a yes-no answer. And we're going to randomly select them from across Australia. Now, we can use the normal approximation to the sample proportion distribution to find the probability that our survey will yield an estimate that's within 0.01 of the actual value. So if we know that 1/4 of Australians like anchovies, then when we carry out this survey, what is the chance that we get an estimate that's within 0.01 of that? Now, if 1/4 of them like anchovies, that's 0.25, so let's think that through straight away. So we've got two methods that we can use here. We can use the proportion methods that we've learnt today. This is the new stuff in red. Or we could use our old method. Now, I'm going to actually do the proportion side first, and then we'll come back to that. If we say P with a hat on top of it is the proportion of people that like anchovies, then we've been told that that is 1/4. So that's what we're expecting. And the standard deviation of that proportion, we've got a formula for that, PQ over N in the square root. And so that's 1/4 times 3/4 over 2,000. That's where that number comes from in the square root, and that's roughly 0.0097. Now I've saved that in my calculator as B. That's the standard deviation. So when we say, all right, what are the chances that our survey is going to tell us that the proportion of people like anchovies is only 0.01 off what we know it really is, we're effectively saying there, what's the chance that the proportion comes out in the survey as being between 0.24 and 0.26? So here we've got a proportion. We want to use the normal distribution to estimate this. So we've got to turn our proportion into a z-score. The way we do that is we say, how far is this number and this number above or below the mean? How many standard deviations is that? So 0.26 minus 1/4, 0.25, is 0.01. We divide that by the standard deviations to see how many standard deviations it is, and it turns out to be 1 and a bit. So what we're saying is here we're going 1 and a bit standard deviations above or below the mean. So looking at my z-score then, to say what's the probability that a z-score is less than 1.03, remember our z-score table just gives us all the values to the left of that number. I get this, 0.8485, so roughly 85% of the scores are to that side. So if I want to know how many of the scores are between negative 1.03 and 1.03, just in this little bit here, there's a few ways I can do it, but I think the easiest way is to take this number, the probability that z is less than 1.03, to the left of that line, take off 0.5, because I know that everything on this side of the y-axis is half the scores, so take off 0.5. That'll give us just this bit here, and that's going to be half of what we want, so now we can double it. So I've got my 0.8485 minus 0.5, so that gives me 0.3485. I double that, and this is what I get. Now, what does that mean? It means there's 69.7, let's round that and say, because this is an estimate, there's roughly a 70% chance that when I carry out this survey and ask these 2,000 people if they like anchovies or not, there's a 70% chance that the answer I get from them will be within 0.01 of what I'm expecting. So that's a pretty good chance that my survey group are going to conform to what I know of the larger group. So that tells me that 2,000 people is probably a fairly good sample size. Now, maybe I would like to find what are the chances that it's between, 0.23 and 0.27. I could put in whatever parameters I like, but the methodology will be the same. Now, how could we do it if we didn't know how to work with proportions and we just used the number of successes? Well, we could actually work just fine. We could just say, let X be the number of people that like anchovies. We'll just let our variable be an actual number of people. So that means the mean is just going to be n times p. So we're expecting a quarter of the 2,000 people. We're expecting 500 people to like anchovies. That's the expected value. The standard deviation is the square root of NPQ, so we know how to figure that out. It's roughly 19.36. I've saved that in my calculator as A. So now I've got to think, well, this is the part where the thinking happens, and that's why I suppose our textbook has said, hey, that thinking's really hard, why don't you do it this way? But if this way doesn't make sense to you and this does, then this is good thinking to do. I'm thinking, okay, a quarter of 2,000 is 500 people. So if I want to find the probability that the sample proportion is 0.01 above that or 0.01 below that, I'm thinking that's 1% of the people. Now, 1% of 200 people is 20 people. So what we're really saying is, what's the chance that when I survey these people, there's going to be between 480 and 520 people that like anchovies? That's effectively what we're asking over here, doing the same working. Now, you'll notice here I haven't accounted for the continuity correction, the fact that this is discrete data, and I'm approximating it using the z-scores, which are built on continuous data. Now, if I don't account for that, then I can find these z-scores here quite easily by just saying, well, 520, how far is that above the mean? How many standard deviations is that? I can see it's 20 above the mean, and 20 divided by the standard deviation, you can see why it's 1 and a bit. 20 divided by 19 and a bit, it's going to be around there. And you'll notice that's the exact same figure that we got over here. So this working works out fine, and curiously, when you're using the proportion method with these formulas, it's exactly the same, as we've already seen in the last example, as when you work without the continuity correction. Now, I've already acknowledged that perhaps it is more mathematically sound to account for the continuity correction, which means that if we're finding all of the columns between the 480th column and the 520th column, then we actually need that whole column, so we need to draw the line at 479.5 and 520.5. Now that's just going to change the z-scores a tiny bit, and if we do that, then instead of a 70% chance, I think it works out here as about a 71% chance. Now remember, both of these are estimates. So whichever method you use, either one of those, or this one, by just stating what you've done and showing working that makes sense and rounding off suitably at the end, I think you're going to be fine. So I think take your pick with method 1 or method 2. Maybe do some questions each way until you get a feel for what questions might require this sort of working, or maybe some questions will be easier this way. You'll find out.